What is up, guys? Welcome to Bardent. My name is Heinrich, and today we're going to take a look at how we can make it so that our enemy can detect our player. This is what we ended up with in part 13. Our enemy is currently patrolling left and right, and if he detects a ledge, instead of just turning around and moving immediately, he will idle for a random amount of time, and then turn, and then move. So let's take a look at this little state machine diagram that I have created here. This is for this specific enemy, and it just shows all the different states we plan on having by the end of this, and then how the different states transition to each other. Let's just zoom in here. So we currently have our moving state and our idle state. So as you can see, if we detect a ledge or a wall, we go to our idle state, and then if the idle time is up, we go back to our moving state. So logically, the next state we would want to implement is our player detected state. So this is where the enemy has now noticed that the player is in range and needs to go into like an aggro state or something. So before we start doing this, I just want to list the steps that I follow when I make a new state with the current system that we now have in place. And I'll list it up here for you guys to reference if you want to make your own states. So step 1 is to create the state class. So in this case, it'll be the player detected state class that is going to inherit from state. In this class, we're then going to do all the things that we need to do to detect the player or look for the player. Along with this, we need to create the state data class for the specific state. And then we also need to create the enemy specific state class for player detected state that is responsible for the transitions between the different states. And then the last thing we need to do is just declare the state on the enemy class. Okay, so let's jump into Unity and get started. So let's head to our states folder, and then let's create a new C# script. And then this is going to be our player detected state. Like that. We can go ahead and open it up so long. And then while it does that, let us go to our data folder. And then let's create the data script. So new C# script, d_player detected. And let's go ahead and open that up as well. And then next, we need to come to our enemy specific folder, enemy1, and then create a new C# script. This time it's e1_player detected state. And then we can just go ahead and open that up as well. So now we have all the files we need for this new state. We have our player detected state, our data class, and then our enemy specific class. Okay, so let's start with our player detected state. We can go ahead and delete all the pre-generated code as we do not need it. And then we can make it inherit from state instead of monobehavior. And then we can come and generate the constructor with control full stop, generate constructor. And now we just need to get the reference to our data class. So let's make a protected d_player detected. And we'll just call it state data. And then let's add that to our constructor. So comma d_player detected. And then again, we'll just call it state data. And then finally, this dot state data equals state data, like that. And then next we need to get the overrides for the functions. So we can just click on the class name again, control full stop, generate overrides. We do not want the equals, get hash, or toString functions. Click OK, and now we have all of our override functions. Okay, now we need to think about how do we want the player detection to work. We're going to keep it simple and just use a single raycast that is shot out from the front of the enemy at a certain distance to look for the player. But instead of having one ray, we're going to use 2 rays at different distances and say if the player enters the smaller distance, then the player is detected. And then while the player is in between the smaller and the bigger distance, it stays detected. And the player is only considered to not be detected once he leaves the longer distance. This is also something that is going to stay consistent across most of the enemies. So we can write another function in our entity class to handle this for us. So let's come back to our entity class and do that. We're going to write 2 new functions. The first one is going to be a public virtual bool. Again, this is basically going to work exactly the same as the check wall or check ledge functions. So we'll call the first one check player in min aggro range. So this function is going to take care of doing the shorter distance check. And the next one is going to be a public virtual bool check player in max aggro range. Like that. So we need to define what the min and max aggro distances are for the enemy. So let's go to our d_entity class, and then let's create two new public floats for those distances. So we have a public float called max aggro distance, like that. And by default, we'll just set it to 4. Why not? It doesn't really matter. It's just so that we don't have any errors in case we forget. And the next one is going to be our public float min aggro distance. And we'll just set that to 3. I'm actually going to move this up above max. And then, seeing as we're going to be looking for our player, we also need another layer mask that is what is player. So public layer mask what is player, like that. Back in our entity class, we're almost ready to actually fire the ray. Now we just need to have a position to fire it from. So let's do the same as we did for wall check and ledge check. And let's come up and declare another serialize field, private transform, and we'll just call it player check. And let's come back down to our two functions, and now we can say in our check player in min range function, we'll say return physics2d dot raycast, and we're casting the ray from our player check dot position, and we're firing it in the alive game object dot transform dot right direction, and we're using entity data dot, and this is our min function, so we're using our min aggro distance, and then finally entity data dot what is player as our layer mask. In our check player in max range function, we can do the exact same thing. We're firing it from the same position, same direction, except we'll be using max aggro distance instead of min aggro distance. Now our player detected state isn't responsible for actually detecting the player. This is just where we go once we have detected the player. So we need to take a look at our state diagram again and see, okay, we can detect our player from our idle state and our moving state. So in these two states, something needs to happen to see if we can move to the player detected state. So let's start with the move state, and let's come up to our variables, and we'll start off by declaring a boolean to hold whether or not the player is currently in the min aggro range. We do not want to consider the player detected once we enter the max aggro range, only once we enter the minimum aggro range. So we'll say protected bool, and we'll just call it is player in min aggro range. This name might seem a little bit long, but it helps in the long run to use descriptive names. And then in our enter function, we can just say is player in min aggro range equals entity dot check player in min aggro range. Easy as that. We then just want to make sure we copy this and put this in our physics update function as well. And let's go ahead and do exactly the same thing in our idle state. So we'll declare another protected bool called is player in min aggro range, like that, and then set it in our enter function. So is player in min aggro range equals entity dot check player in min aggro range. Copy and paste that in our physics update, like that. So now both our move and our idle state will know if the player is currently in the min aggro range for the enemy. We'll take care of transitioning to the player detected state from our enemy specific state classes. So for now, let's just set up our player detected state. In the player detected state, we want to keep track of if the enemy is in our min aggro range and if the enemy is in our max aggro range. So let's declare two protected booleans. So protected bool is player in min aggro range, and protected bool is player in max aggro range, like that. And let's immediately go to our enter function and set these booleans. So is player in min aggro range equals entity dot check player in min aggro range, and then is player in max aggro range equals entity dot check player in max aggro range. Let's copy and paste that to our physics update function, like that. Okay, so for now what we're going to do to check if our player detected state is working or not is just when we detect the player, we're going to stop moving the enemy, go into the player detected animation, and then when the player leaves the max aggro range, we'll just go back to the idle state. So nothing else has to happen in the player detected state class. For now, we'll head to our E1 player detected state, and then we can just delete the pre-generated code and then make it inherit from our player detected state, like that. We can generate the constructor with control full stop, generate constructor, and then we need to get a reference to our enemy. So we have a private enemy1 that we'll call enemy, add that to our constructor, and then this dot enemy equals enemy, like that. And then we can generate our overrides. Again, we don't want the first three, we only want those. Click OK. And now in our logic update, we'll take care of transitioning to the different states. So first, we actually need to get to our player detected state. So to do that, we first need to come to our enemy1 script and declare our player detected state so that we can transition to it. So we'll add a public E1 player detected state, and we'll just call it player detected state. Add the getter and the private setter. And then we need to get a reference to the data. So serialize field, private d underscore player detected. And we'll just call it player detected data, like that. Then, seeing as we already have our constructor set up for our E1 player detected state, we can then create the instance. So we'll say player detected state equals a new E1 player detected state, and we'll pass it this as the entity, state machine as the state machine. The animation boolean name is just going to be player detected. So the convention that I use for the boolean names is just the state name without the state, and then we use camel casing where the first word is lowercase and then every word after that starts with a capital, just to keep it consistent. Although I am notoriously bad at not keeping that very consistent, but I'm trying. Okay, and then we'll pass this as our enemy1, like that. Okay, now in our E1 move state, we can transition to our player detected state. So what we'll do in here is we'll come into our logic update function and we will say if is player in min aggro range, meaning the array has detected our player, then we want to transition to our player detected state. So state machine dot change state, and the state we want to change to is enemy dot player detected state. Simple as that. And then after this, we'll just change the second if to a else if, because we don't want this accidentally overriding the other transition. And that's all we need to do in the E1 move state. Next, let's go to E1 idle state. And here we can do the same thing. So if is player in min aggro range, then state machine dot change state to enemy dot player detected state, like that, and then change this to an else if. So now when we come in range, we should detect the player. Now in our E1 player detected state, just to test it out for now, in our logic update, we will say If not is player in max aggro range, then we want to transition back to our idle state. So we'll just say state machine dot change state enemy dot idle state. And we don't want the enemy flipping after the idle state. So we'll come up here and we'll say enemy dot idle state dot set flip after idle to false. Now if we come back to Unity, oops. Okay, so we have an error, and that is because we forgot to pass the state data through to the state. So after our player detected Boolean name, we'll just say player detected data, like that. Okay, that should be good. Make it inherit from scriptable object, and make it so that we can create the asset just so we can put it into the inspector so we don't have errors. We'll come back and add the things we need in here later when we get to it. So we can say square bracket, create asset menu, and then the file name. Let's just go back to our other data class just to confirm what we have. We'll just copy this actually. Wait, this is entity. We want our state, so let's copy this in here, like that. And we'll change it from new move state data to new player detected state. So menu name is data, state data, player detected state, like that. Okay, now if we go back to Unity, in our enemy specific enemy1 data folder, let us right click, say create data, state data, player detected state. And we'll just call it E1 underscore player detected data, like that. Now, if we click on our enemy1 game object, we can drag this into our player detected data. And now we also just need to add the player check game object. So let's go to our alive game object and create a new empty game object. Call it player check. Go to enemy1, drag player check into the slot, and then let's just move it to a better position. Whoops. I'm gonna move the player check to around, actually not in front of the player. We want to put it inside of the player, around there. That way, if we get really close, it'll still detect the player. So about there is fine. Okay. So now if we look at our enemy1 game object and look at our entity data, as you can see, our min and max aggro distance, the default values have been added. So our max aggro distance is about 4 units, which should be around here. And then our min is 3. So we have to get about this close before the enemy actually detects us. Now let's just set up the animation so that we can see whether it actually worked or not. So let's pull up our animation window. Click on our alive game object so that we can create a new animation. Navigate to the animation folder. And we'll just call it enemy1 underscore player detected. Like that. We're only going to use 1 frame for this, so the sample rate doesn't really matter. We can come down to our sprites folder, our enemies, and let's see which sprite we want to use. I'm just going to use one where the enemy kind of has his arms up. So here's our attack animation. I'm going to use this frame of the attack animation to represent our player detected. So the enemy's kind of getting into like a combat stance. Just drag that in, and then if we go to our animator, we can see we have our player detected state. So we can just put the animation window away for now. And now let's look at our animation states. We need to remember to add our player detected Boolean. And it's very important that this is exactly the same as we have it in the code. And then the transitions between the animation states is going to be very similar to the transitions we have on our state diagram over here. So let's make a transition from our walk state to our player detected state. We want to untick has exit time and set the transition duration to 0. Just in case you don't know what these do, basically exit time means how much of the animation we're transitioning from has to play before we can leave. So if our transition had no conditions and exit time was set to 1, that means the walk animation would play all the way through once and then transition. This is why it's important to set these to 1 on like our attack animations where we have an animation event at the end of the animation. If the exit time is not set to 1, that animation event might not be played. Transition duration just has to do with how it blends between the two different animations. Because we wanted to instantly transition from our walk animation to our player detected animation, we set the transition duration to 0. So now let's add our conditions. As usual, we have two conditions. The first one is that move is false, because we're transitioning from walk to detected. And then the next one is that player detected is true. Now we can do the same for a transition from idle to player detected. Untick has exit time, set the transition duration to 0, add two conditions. First one has to be idle is false, and the next one, player detected is true. So now when we leave our max aggro distance, we want to transition back to our idle state. So let's make a transition from player detected back to idle. This is just temporary, just for testing. So let's click on the transition. Untick has exit time, transition duration is 0. Add our two conditions. So the first one is player detected is false, and the next one is idle is true. Perfect. Okay, let's test it and see if we did everything right. So if we run this, okay, and one last thing before this is going to work is in our entity data, we also need to set what is player equal to player. Okay, so now if we run the game, when we get close to the enemy, you can see he detects us. It's not quite right yet, and I know why. And that is because we forgot to stop the enemy when we go to the player detected state. So if we go to our player detected state in our enter function, we need to say entity.set velocity to 0f. So now if we run this, jump in front of him, as you can see, he goes into his little combat stance. He's detected us. Now if we move left, he'll go out of it because we're no longer in front of the ray. As you see, when he turns around, he detects us. If we move out of the max aggro range, he goes back to his idle state, and he doesn't flip after idle. Perfect, so our player detected state works. Let's take another look at our state machine diagram. So once we've detected the player, we have two other states that we could transition to. So if the player is detected for a certain amount of time, the enemy is going to charge at the player. Alternatively, if the player is detected but the player is close to the enemy might just attack the player immediately. And as you can see, if we charge at the player and we get in range of the player, we will also attack the player. So next we're going to take a look at creating these two states. I hope you guys can start to see how this is coming together and how easily we can create more states and more behaviors for the enemy. And I can't wait to show you guys how simple it is to create a second enemy by reusing a lot of this code. It's actually amazing. Again, if there's anything that you guys don't understand or something that I did not explain super well, please reach out to me in the comments or on Discord and I'll be happy to explain more. And yeah, so again, I would just like to thank all my supporters and wonderful people on Patreon who really help motivate me to keep this series going. And a big special thank you to the absolute mad lad, Lewis, for your support on Patreon. I hope you all have a wonderful day.